Okay, in this video, I want to continue talking about x and y intercepts, whether whether a point is on the line, and yeah. So let's keep going. So for this example, find the y-intercept and the x-intercept of the line y equals 3x minus 6. Okay. Well, one strategy is you could graph it, but I want to show you a way where you don't have to graph it. In the previous video, I showed you that if we're looking for the y-intercept, that the x value has to be 0. So I'm going to go ahead and put a 0 there. Now, if x is 0, what would y be? Okay, so that means that I plug in 0 for this x here, and 3 times 0 is 0, and so y would simply equal -6. All right. Now we can say that the location or the ordered pair would be 0, -6 for something like this. All right. So I hope that makes sense. Again, if you're looking for a y-intercept, the x has to be 0, so you can plug that in, and then you can find what the y is. Okay, well, if we're looking for the x-intercept, I know that y must equal 0, so I can plug that in. Now, if y equals 0, this is going to be 0 equals 3x minus 6. I can add 6 to both sides. I get 6 equals 3x, and that implies that x must equal 2, because 2 times 3 is 6. So we found that this is 2. Okay, and that means that the location or the ordered pair would be 2, 0. All right. Again, that's how you can find it without even graphing it. Of course, you can graph it, but you don't have to. You can just plug in 0 for the respected point, and then, or the respected variable, and you're good. All right. Now, moving on, determine if the points are on the graph, and it's y equals 2x. Okay. Well, it says graph. Well, where's the graph? Okay, so you can draw it out, but I think it's a lot easier to just plug in the numbers. So that's what I'm trying to show. So y equals 2x plus 3, I'm seeing is -2 and -1 on this line. Are they on the line? Well, then I can plug in -2 for x and -1 for y. So I'm going to do that right now. So it's -1 for y equals 2 times -2 plus 3. Okay, so is this true? Well, 2 times -2 is -4, and -4 plus 3 is -1. So this means that -1 equals -1, and that's true. So yes, this is on the graph. Whoops. Yes, this is on the graph. Okay. What about 3, 9? Is that on the graph? Let's see. I'll plug in 3 for x and 9 for y. So 9 equals 2 times 3 plus 3. All right. Well, 2 times 3 is 6, and 6 plus 3 is 9. Yep, that works. 9 equals 9. Yes, this is true. The point 39 is on there. All right, let's try 5, 12. 5 for x, 12 for y. 12 equals 2 times 5 plus 3. So 2 times 5 is 10, and 10 plus 3 is 13. So 12 equals 13. No, that is not true. So this point is not on that line. They have to equal on both sides. All right. Well, let's plug in 4, 6 and see what happens. So 6 is for y. 2 times 4 plus 3. 2 times 4 is 8, and 8 plus 3 is 11. So that is not true. That is not true. So no, that's not true. 6 does not equal 11. All right. Well, what if you were given a graph? So I have a graph here. What if you're given a graph, and how can you find the x and y intercepts? Well, with something like this, I can just count. So the x-intercept happens right here. So that happens right there. And where is that? 1, 2, 3, 4, 5. Okay, but it's going to the left, so that would be -5, 0. Okay, so that'd be the x-intercept. Now what about the y-intercept? The y-intercept is right here. And where is that? 1, 2, 3, 4. 1, 2, 3, 4. And that's going down, so that's negative. You can see the negative 6 there. So that's x equals 0, and then negative 6 for y. Okay, so that's how you can do them. I mean, they're pretty easy problems, but you can just count the boxes, and if you're given a graph, it's easy. If you're not, sometimes you can use other techniques rather than just graphing it. Graphing is very time consuming, so you can use other techniques to just find the answer. All right, I think that's enough for this video. Next video, I'm going to go into distance and midpoint. So I'm going to cut this one a little short, and I'll see you in the next video.